So as you can see, we have changed the Henry value into an ohmic value for the inductor. So we go back to my circuit and I replace the Henry value, the inductor's value, for an ohmic value for the inductor. So now as you can see, I have ohms for the resistor and I have ohms for the inductor reactance. Okay? Now these two can be combined to get the overall resistance for the circuit. However, because this is not a resistor, but it's an inductor, you cannot just add the ohmic values, 60 plus 1884.95. You do not add them that way. In order to add a resistor to an inductor, you use this formula. And the result you're going to get is called the impedance. And of course, the impedance has the letter Z form. So let's go ahead and replace our values. The ohmic value for the resistor was 60 ohms. So I'm going to replace it. 60 ohms squared plus the inductance reactance for the inductor, which is 1884.95. Don't forget to square it. All right. So now you just need to calculate this. Use your calculator. You take the square root of 60 squared plus 1884.95 squared, and I get 1885.90 ohms. Now, one thing that you need to notice is how, even though I have a 60 and an 1884, it did not add linearly. I didn't get 1884 plus 60. It's barely 1885.90. And that's because of the way that we use this addition for the impedance. But now you see that it has an ohmic value, and this ohmic value is for the entire circuit, right? So do not get confused between the impedance and the inductor's reactance. They're all ohmic values. It's all added for resistance. But this will help us calculate the total current in the circuit, as we see next.